Well, let's get going. I'm sure some people are going to be joining us as they work through the usual technical things we all run into with these presentations. Uh, so we'll get going, and we appreciate you being here. My name is Chris Carpenter. I think I probably know many of you. I am one of two architectural representatives, consultants for Pella Windows and Doors here in Chicago. I'm pretty active in the AIA Northeast Illinois chapter. I was on the board of directors, seems like ancient history now, 2014, 2015, and 2016, starting with Leanne Meyer-Smith as a president. And since then, I've been on the board of AIA Chicago, too. I was on that board kind of during the height of COVID, 2020, 21, and 22. I like to, I'm not an architect, but I kind of play one on TV. My dad was an architect. I am speaking to you today, as you saw in the invitation, from Pella's showroom experience center, we call it, here in Northfield. And you can see some pictures of that on the screen. Certainly, all of you are welcome to come here at any time you want, and kind of any level of help we can give you is available, whether you just stop in unannounced or you set up an appointment to meet with me or to bring in customers. And of course, we also have a showroom that's not quite as new as this, but still really up to date in Naperville. So we're here and we look forward to helping architects. So real quickly, as you know, Pella provides products and services for all kinds of different projects. Certainly, just by default, I end up spending a lot of my time on commercial projects because of the complexity and all the different considerations that come into play. And I'm happy to say that Pella is celebrating our 100th year this year. Kind of a trivia thing. Does anyone remember what the original name of our company was? The Roll Screen Company. We didn't become Pella until, I think, 1992. And I'll show you later on, if you can stick around after the program, some of the reasons that we still are affiliated with the term roll screen because of the screens that we're well known for. And we have all kinds of different products. I will just clarify that there was a 10-year period when we owned FCO and provided architectural aluminum storefront and curtain wall. That's part of our history, and these are the materials that we work with today. And we're nationwide, we're international. This map shows where our plants are and our affiliated companies, coast to coast. Some of the companies that are part of the Pella family in the south, of course, are due to the special needs due to the weather they have down there and some of the special products that they've developed because of that. And just very key for all of you are all of the services that we provide, many of which are free. We act as another person in your back room. Through me, you can contact me and say, I have an elevation. What can you do to help me put the windows together? How's it going to perform? How will it work with ADA and thermal performance and structural performance and design and historical and contemporary? Throw things at us and we can help you with the staff of experts we have. All right, today we're going to talk about sound. Interesting subject because it really affects everybody. Sometimes, of course, it's higher on the list than some other aspects of design. So we'll talk about, as we're doing all these education courses, the fundamentals, but then we'll look at some of the practical things that we do and options we have today to provide our customers with better sound performance in their structures. So this, of course, is AIA approved, and you will be getting one learning credit in HSW and certificates as you would like. The objectives, of course, have to do with basics, why it matters, how sound works and is affected by the choices we make in our design, and how we can improve the results and some of the tips and tricks that come with that. First of all, like anything, we talk about some things that we already know a lot about, and that's what aspects of sound are good and what we want to get rid of. I think it's pretty clear that there are definitions for everything, and certainly the EPA jumps in and tells us what noise is. So I don't think any of us needs to understand that any more than we already do, and how sound can be really harmful. The funny thing is, I think that sometimes we're just stuck with it, but it's nice to know that we in this industry up front can design things to really help and give control to people as much as possible in their buildings of that problem, because it really does adversely affect us, or can. It's stressful. I'll share personally that when I went to the audiologist the last time, she said, guess what? You're a candidate for hearing aids. And I thought, back to when I first was told I needed glasses, I thought, oh, that's, yikes, that's unfortunate. But I decided to try hearing aids, and wow, I wore them for almost a week, and I decided that I was going to wait. It helped, but there were trade-offs, just like anything. And I'll show you some examples of some of the trade-offs when you're trying to help reduce noise in a building. So for now, I decided to opt out. But let's say when our daughter was in college, one of the best gifts we ever gave her was a pair of noise-canceling headphones, because it just helped her block out that unwanted noise, even if she wasn't listening to anything, just quieting down the surroundings. So it can have a big effect. And of course, government jumps in and tries to help with legislation for things, in some cases that require an investment to try to improve people's lives. And it does really make sense to have sound as part of the strategy for health, productivity, and comfort. I think we all know that. So that's why we're here talking about this. There is such a thing as a document that the Department of Housing and Urban Development put together about controlling noise in structures. And they've identified 4 things which sometimes I think are common sense, not always. You can eliminate the source. You can find materials that will absorb the sound. You can use a barrier, and then you can mask some of these things and just try to make them less apparent. Other things I think that we know, that sound travels all kinds of different ways, through air and through materials, both of which come into play when we're trying to design for controlling sound. So how do we do that? What do we measure? We usually measure transmission loss. That is how much we're able to reduce the noise. So if you have sound, it can either be reflected off a surface and we hear it, or it can be absorbed. Some of it might go through on the inside, and that is what we can play with, are some of those factors that control what is reflected and what gets through. So we measure in terms of transmission loss in decibels. When you're talking about sound, there are a couple of things, major kind of ways to look at it. Sound pressure is really how loud it is. And I admitted that I could use hearing aids. And part of that is not just that things aren't loud enough. Part of it is I can't hear all of the frequencies. So that's the other thing, is sound pressure, which is kind of volume, and frequency, which is the high-low of what type of sound it is. And those, if you look at sound pressure, pretty obvious that we have some pretty loud things and some soft things. And usually human speech comes in somewhere whispering down in this lower area. But that's all over the map, and usually every 10 decibel reduction in sound is perceived as about half the loudness. So a 10 decibel change reduces to our ears by about half the loudness, comparing the measurement to the effect. Frequency is kind of the they're measured the high-low frequency, the vibrations. It's, middle C on the piano, for example. So if you look at some common sounds where they fall on the frequency range, dental clinic noise is a scary one, right? You think of that high whine of that drill that you don't want to hear, but there are some other things in a dental clinic that could be high or low. But if you look at something like noise coming through walls, typically is a low frequency. Things like an alarm clock are going to tend to be a higher frequency, or noises that come from your phone, mobile notifications. Apparently, those are something that get our attention a lot more than maybe the noise of a truck that would be coming through a wall that we can live with more. You wouldn't set your alarm clock to sound like a railroad track 5 miles away, but you would like we hear on our phones because of the frequency affecting us differently. So we all, I think, are familiar with STC rating, sound transmission class. And that's something originally that was developed to deal with partitions and how they attenuated airborne sound in an office, let's say. So those have been applied, kind of taken more than just for partitions, also to windows and ceilings and floors. That's a common measurement that we're used to. And how is that determined? What the STC rating is of any particular product, let's say windows in this case. So you'll usually have an acoustic lab. This looks like a typical setup where you have a couple chambers. You have one where there's a microphone. Then in the middle, you'd have the window isolated so that it's only being influenced by the sound and not anything else like coming through the wall, from the wall itself. And then you'd have the microphone in one chamber, and in the other chamber, you'd have the source of noise. So typically, the window's completely sealed around, very carefully around the perimeter, because as we know, that really matters in what's transmitted. And then they play a continuous random noise at frequencies between 125 and 4,000 hertz, which is kind of the typical range of human speech. That's the standard they use, is that range that equates human speech. And they take readings with their instrumentation at every 16 1/3 octave frequency band intervals. So if you're a sound techie, that'll mean something to you. Let's then look at how they record that. Beautiful charts if you love charts. What you see here is that they plot a dot whenever they play that random sound in that one chamber of that test lab. So that first dot is at 120 hertz. And that is the transmission loss that window achieved when they hit the button and played 120 hertz sound. And you see there's a solid line that's a kind of a baseline curve, a reference contour, they call it, that has been predetermined. That is what they're shooting for, what's kind of ideal for these products. And when they hit the button and make that sound, they measure the transmission loss and they chart it to see how it compares to that solid line. So if you see that going to the right is hitting the button, it plays higher and higher frequencies. So when you get up and they hit the button, higher frequencies, all of a sudden in this range up here, like between 630 and 1600 hertz, the window is blocking out it has a higher transmission loss. It's blocking out more sound than the reference contour would suggest it should, I guess. So what they do to figure out the STC rating is they move that solid line up and down until the sum of the deficiencies is less than 30, I think. It does not exceed 32. So let's take a look here. When they hit the button at 120 hertz, there was no deficiency. It was right at the line. When they got up here in the higher frequency, there's a gap between how much the window blocked out. It blocked out better than the line. So there's a number there and a number there. That deficiency is 0. You get down here where it performed worse. So there was a gap of 8 worse than the line. So you add all those up and they move that line. So the sum of all of those numbers right here is less than 32. And then at the point where they meet, that is the STC rating. So in this case, where that green star is, those two lines meet at 50. So they say that's kind of the average, a fancy way to figure out what kind of the average performance is for that window. Keep in mind later, we'll do a case study where you realize that windows don't just perform at one number for everything. Keep this in mind that if you're really concerned about, let's say, a train noise, that might be a really low rumble. So you might want a window that really does well at low frequencies, or if you're next to a fire station with sirens, it might be a different thing. So just keep that in mind. Okay, how can we control this with materials and that we pick? We probably know that density matters, how thick it is, and then things like variations and certainly air leaks are something a lot of people don't stop and realize really contribute to sound. Having been a service manager in the window industry, I've run into this many times. People, it also goes for air and water infiltration. People tend to want to find something to blame, and of course, it's easier to blame the window than the installer and thankfully the architect, right? But often it's not the window, it's the lack of proper installation. That's true of not just windows, but a lot of things. So air leaks are a common thorn in the side of sound. Let's talk about interior wall construction as an example. So if we look at the top picture here, this is a section of a wall that has 2x4 studs, 16 inches on center, and some half-inch gypsum board screwed to the studs. If you put that in that test chamber, that might give you an STC rating of 28. If you want to improve that a little bit, put some drywall on the inside. Pretty common sense. That improves the STC rating to 34. If you want to improve it even further, put some sound attenuation blanket in there. That can go up to a 37. Now, this is an odd thing that maybe we haven't thought of. If you move the studs further apart, that can increase the STC rating. One of those trade-offs. You might not want to do that because that makes the wall less rigid, but it improves the sound. So it's one of those trade-offs. If you had studs every 3 feet apart, you might have better sound attenuation, but you'd have a pretty weak wall. So that's where we get involved in a compromise. Now, if we flip and look at the exterior, if you just had bricks alone and you tested the sound, that might be an STC rating of 45. There's a lot of mass with the bricks, and that performs pretty well. But you can still improve upon that by adding other things. If you added an airspace, insulation board, 2x4s, a resilient channel, and gypsum board, that could boost it up to an STC rating of 54. And if you threw in some fiberglass building insulation, in this case, 3.5 inches, that raises it a couple of more points up to an STC of 56. So that gives you an idea of some of the principles we talked about. Mass, confusing distances between things, air spaces, the density of materials, all having an effect on sound. Now, if we had the luxury of simply focusing on how to take care of sound, we could do that if you're building a data center or something with no windows. But we need to worry about it because we need ventilation and daylight. So that's where we get into considering windows. And here are some common solutions for glazing. So just to get oriented here, these are some typical assemblies that you'll see offered to you in windows. So let's look at how the arrangement and composition of these insulated glass units or whatever affect sound. So on the left, we have a typical 11/16 overall width insulated glass unit with 3 mil glass on both the interior and the exterior. Pretty cost effective, common. That would have an STC rating of, let's say, 26. So if you want to improve it, what's one of the principles is varying the thickness of the material. So if on the exterior we had a 3 mil pane of glass, we put a 5 mil pane on the interior, that really boosts the STC rating up to 30. Same airspace, just different glass thickness. If we look at triple glazing, a lot of people say, I want to go to triple glazing. That's going to really improve the performance. Well, it improves the thermal performance more than the sound performance. I think you probably know that. If you had all three panes at 3 mm, your STC rating is not as good as just the two panes of glass with different thicknesses. It's only a 27. Now, if you really, really care about sound and you have the budget, this next one is probably the way to go, because laminated glass is one of the best ways to take care of a sound problem. You're creating something that's so dense and confusing to sound that you get a 36 STC rating. Now, the one on the right here is triple pane. What's different from this triple pane? Well, you can see that the air spaces are not the same. So even though the glass is all 3 mm, the sound gets a little confused because it's different air thicknesses between them. Sound gets confused. And the STC is 33 versus the 27 for conventional triple glaze. If you have triple glaze that's got two different air chamber thicknesses, you improve from a 27 to a 33. And these are all based on an example window that's 48 by 60, a fixed window. So whether it's fixed or venting, the frame, all those sort of things also have, of course, an impact, as does around the outside, obviously. We'll touch on that shortly. Now, you're probably also familiar with the other major way to measure sound is the OITC, or the Outdoor-Indoor Transmission class. This was developed because it better measures exterior glazing assemblies because of how pervasive the problem is with some of these low frequency sounds that we get from traffic and railroads and rumbling of bridges in the street and all that sort of thing that travel so well long distances and really affect, sometimes we don't even realize, but it's important. So the OITC rating is more and more commonly used than STC. Now think back to that graph we had with that contour. OITC is arrived at by changing that reference contour and weighting it more toward those lower frequencies. So it just, if we look back then at how that compares when you measure by changing that reference contour in your testing lab, the same principles apply. The numbers, though, change. And because we're looking more at lower frequencies, the differences between some of these assemblies are not exactly the same as they were measuring just the STC, which focuses more on higher frequency. So still the best thing we see here is a 30 with the laminated glass. We see that triple pane with different air spacing is still better, a 27 versus a 22 with conventional triple glazing. And you see that a 25 with mixed millimeter glazing is still pretty efficient, a good bang for your buck if you're looking at OITC compared to triple glazing in your glass specifications. All right, well, let's speaking of bang for the buck, one really good thing is to stop and think about your investment in glass for sound improvement and what makes sense. So this is a chart that tries to help us understand that. What we have on the left is the perceived sound reduction from 0 to 100, like taking away all the noise. And then on the bottom is the STC rating. So windows that are at a 25 would be over here. Windows that are at a 40 STC would be over on the right. So if you look at deciding, let's say, between two choices of windows, one that is a 25 STC rating and one that's a 30, between those two, 25 and 30, you'd only have like a 5% noticeable difference in sound. So that would be, on one hand, an 82% reduction in sound and a little bit higher at a 30. Now, if you look at the difference between a window that's a 30 STC and a 35, that is less than 4% perceivable difference, but the cost goes way up. And then if you look at deciding between a window that's got a 35 STC and a 40, the difference there is only 2.5% distinguishable, which they're calling indistinguishable. So generally what this shows is that it's probably not worth paying for a window that's a 40 versus the 30 STC, because you're not getting much difference in the sound improvement for all the money you're going to spend. It's pretty hard to get to an STC 40. I think we showed an example a few slides ago where there was a, if we go back here, we had a 33, 36 here with laminated glass. So if you have a 36, that's pretty high if you go spend money on laminated glass. It takes a lot more money, usually sometimes even a storm panel, to get to a 40. Or you can go to something like this. Has anybody ever specified double hungs, 4 sashes? I've never actually seen one of those windows, but that would be pretty good sound performance. Trade-offs, obviously, what it looks like, how you have to go and slam all these sashes shut if there's a rainstorm. Another thing would be some sort of acrylic storm panel, which sometimes can be a good option, maybe more so on the interior because of water and considerations for condensation that might form in between, that sort of thing. That you may have found is something that's looked at often in cases where you have a really historic or stained glass window or something where you want to leave that intact and not disturb the external appearance of it. I mentioned air leaks. They're a huge source of noise. And in the wall section, it can come from any point of the window. One thing I noticed when I was in service, very common that people did not lock their casement or double hung windows. They thought locking was, oh, you know, I'm not going to get broken into. I don't need to lock my windows. And sometimes it's hard. You have to push the sashes. But that makes them perform worse thermally, and it also lets noise in. So we always recommend people, if they want the best performance for thermal and sound, is to lock the windows, because the seals really matter, both on the exterior and on the interior, because sound travels really well through air. And if you invest in a great window, if the sound gets around it, you're wasting your money. Of course, we can specify the ratings we want by specific number, by a range. Sometimes there are guidelines we have to follow for a number of reasons. In this case, USGBC, for example, has had recommendations. So there are a lot of reasons that we might want to specify a specific number. What you may find, of course, is that it's really good to look at the individual site you're at for a variety of reasons, because sometimes it'll depend on the occupancy and all the sources of noise around you and the cost and how it's going to, energy performance is going to come into play. So there are just a lot of specifics tied to your individual project and your site. A lot of our customers find that it's good maybe to look at how they can be more efficient about their investment in windows that are high performing for sound and not use them everywhere. Have an expert come in and tell you what elevations of a project would really benefit from having high performing windows for sound. You may not have to use those in the whole project or on all floors or all elevations. So that's where the investment in a sound study would really probably show itself. Now let's look at a specific example of a school and how it came out in the wash when they specified a certain performance level of OITC for the windows on a project. So this is a school, and they had a sound study done. The project spec said they wanted a 31 OITC on the windows. When it came out in the wash, there are two products, A and B. Product A had a 31 OITC, which met the spec. Product B did not. It only had a 30 OITC. But guess what? They accepted that one. Why is that? Well, remember I mentioned that when we're figuring out what the rating is, that's kind of an average. But at certain higher or lower frequencies, that window could perform different than that average. And in this case, what was really important, they found out, was the kids were screaming on the playground, and they measured that at about a 1250 hertz level. So let's look at how those windows each perform at the critical point when the kids are screaming, 1250 hertz. So here they found out that you could see at 1250 in this case, the window performed at a 31, and this other product B performed at a 39. Even though the average was 30 at that critical hertz performance level for screaming kids on a playground, it performed better, so they went with the one that didn't meet the spec. So that's just one example of what you can run into. Okay, well, in my ever continuing quest to be efficient with presenting these, I have reached the end. I think we hit the objectives. We talked about why sound matters. I think some of these things are just so common knowledge that we don't need to pound that into everyone's head too much. But some of the takeaways I think we can see here now that I've ended the AIA presentation, I'll show you a couple of things particular to Pella that we found are helpful maybe. First, are there any questions about the presentation itself before I move on?
I do. I just real quick. Are we going to be able to see? I had a lot of audio and visual issues this morning, so I kind of missed a little bit of the beginning. Are we going to be able to find this filed anywhere?
I can send the slides, Becky.
Yeah, and just to jump in, yeah, this is being recorded, so
Okay.
we will send that recording to everyone afterwards, and then, yeah, as I think what you were going to say, Chris, is you'll have the slides available.
Yes.
Okay,
Okay.
sounds good.
Great. Thank you.
Uh-huh.
Okay, well, certainly if you want to contact me about individual questions, I'm always around to help with your specific projects. But a couple of things, I'll go back, I'll go to some specific products of ours that I pulled out from my samples just to see how they compared. And on the top of the screen, I've got little snippets from the presentation that showed the makeup of the glazing assembly. So you can compare that to what you just saw in the program to what a real life example would be. If you look at the corner section on the left, that is Pella's, one of Pella's versions of triple glazing with differential air spaces. So you see there's a regular IG unit, like you see in the diagram up here. It's kind of reversed interior to exterior in the diagram. But here you can see there's a regular IG unit. And then there's a bigger airspace, and there's, in our case, what is actually a hinged panel, but 3 panes of glass. So the key is here you have, it could be any different variations of thickness of glass, or they could be all the same. But one key difference is that the air spaces are different in this assembly, which is good for for sound attenuation. This is Pella's Lifestyle Series triple pane. It also comes in just a regular dual pane. And this would allow you to have blinds between the glass, for example. But let's look at what happens if you have just the 2 pane version, both at 2.5 millimeter, that's an STC at 25. If you mix the glazing thickness with just 2 panes, 5 mil and 3 mil, that goes up to a 31 STC. If you had triple glazing where all the panes were the same thickness, that's a 31. So that's the same in this assembly. If you have triple glaze versus dual glaze with mixed millimeter, they're both 31. But if you really supercharge it, triple glazing with 3 different thicknesses of glass, that's a 36. So that would be the best you could do in most conventional lines of windows unless you went to using laminated glass. Now, I don't have a laminated glass example up here, but that would be that or probably close to that or higher. These next two in the middle are corner sections of our fiberglass windows, and in our case, we call them impervia. And these are fixed frame, direct set examples of kind of equivalent to what you'd see with aluminum storefront, just a frame and glass. So in this one, you have triple glazing. You see in the section that we had in the presentation, it's just 3 panes of glass that are all the same, all 3mm. That's an STC of 28. So it falls somewhere between the regular over here and the mixed millimeter at 28 with triple. Now, if you have the same frame, but you have dual glazed, but different thicknesses of glass in that dual glazed IG assembly, same frame, just 2 panes of glass, that's a 31. So you'd be better off going with, if you're worried about sound, going with a dual glazed version instead of a triple in this fixed frame fiberglass window for sound. Now, this is also kind of the same glazing assembly on the right, but this is a casement window in fiberglass. Has the same glass basically as this fixed unit here. They're both fiberglass, but they're different frames. So the STC rating is a 34 instead of a 31. Now that's going to vary with size and all kinds of things. But anyway, that gives you a little sense of, you know, in reality, how these principles come into play with glazing in our case, some of the different products that we offer. Let's see, I've got a little video clip. I'm hoping you can hear the audio, and this is a little, it's a little bit of salesmanship, bear with me, but this guy will give us an example of what it actually sounds like. I'm hoping we can hear this.
Share with you a sound demonstration to show you just how effective our Lifestyle Series triple pane window is at keeping outside noise pollution from penetrating inside your home. When you consider the combination of energy, sound, and value, this is the #1 performing wood window in the industry compared to the leading national window and door brands. What I'm going to do for this demonstration is use this box that has sound dampening material around the inside and a regular Bluetooth speaker. Now I'm going to set the Bluetooth speaker inside the box, and then I'm going to select from an assortment of outside noises that can be disruptive inside the home. Now for this demonstration, I'm going to use barking dogs, as you share with me that that's been a particular problem in your neighborhood. On our Lifestyle Series window, there's a combination of 3 things that provide the sound control that the Lifestyle Series triple pane product offers. First, it's a triple pane product. And Pella's patented triple pane glass design has excellent energy performance and sound transmission ratings. There are 2 other things included in this product that are competitive differences. With the optional sound and ultimate performance packages, each pane of glass has a different thickness, 5mm, 4mm, and 3mm. You'll also notice that we offset the spacing between each panes of glass. Now this unique combination of varying thicknesses and offset spacing helps keep more outside noises out and inside noises in your home. Now for this demonstration, I'm going to play the dog's barking sound, set the window sash on top of the box with the exterior facing down to show you how effective it is in keeping outside noises out. Do you hear the barking dogs? This is how it would sound with an open window. How does that sound? Now I'm going to lift the sash up again so you can hear the sound with the impact our Lifestyle Series triple pane window has, as well as without. Does that sound like the type of window you'd like to have in your home? I'm glad you can hear the difference of the Pella Lifestyle triple pane window.
All right, I think we get the idea. I'll just say that we can help with specific projects you have and with all kinds of things, sound included. But I just would encourage you to contact me and little commercial for our both our residential and commercial teams here in Chicago. We just really love to help architects all the way through the whole lifestyle of a project. And we have a big team here that does that sort of thing. And you can ask us to do a preliminary design drawing showing you exactly how the products will perform for your project. So one other thing I won't get into too much, but just so you're aware, if you hear out in the market, we have a brand new installation method, which is kind of revolutionizing installations that allows windows to be installed from the interior, called Steady Set. It's awesome. It improves efficiency and labor and safety. So I'll be happy to talk to you individually about how that works. And also a big change that you'll see is that Pella, what is Pella known for with our sliding doors? What is one unique thing that has confounded people for decades? Why we had our vent panel on the interior? Well, guess what? We're giving in. We're putting it on the exterior. You're going to see, here's on the top, here's where our vent panels have been historically. You can't see my arrow, but the screens will now be on the exterior, not on the interior anymore on our wood windows. So that's along with the screens that we have that roll up and hide away. You may not have seen that we have screens that, I'll get to that here real quick. We make big combinations. Here you can see new screens we have with both our vinyl windows and our lifestyle series double hung windows that disappear. They're kind of an accordion screen. That's a brand new type of thing that you might not have seen before too. So just some new things at Pella, and I'm always around. And if you want to stop by either our Naperville showroom or our showroom here in Northfield, we'd be happy to host you. So that's kind of the end of my presentation. Unless anyone has any other questions, you always know that I'm around. You can contact me individually and I would be happy to help.
Just real quick, do you have those hidden screen windows in the showrooms?
Yes. Yeah. Check with me first, depending on where you want to go, and I'll make sure that they're not in, they haven't been broken by some kids or something. But
Okay.
yeah, I always check first.
Okay.
Well, great. I appreciate everybody's time today, and I look forward to seeing you in person. And thanks, Becky, for allowing me to bend everyone's ear today, and wish everybody a good afternoon.
Thank you, Chris.
Okay. Thank you, Chris. Thank you for everyone attending, and
Thank you,
I'll
Becky.
send you the recording here shortly.
Thank you. Bye-bye.
Bye.